Good afternoon, dear students.
Good afternoon, madam.
Afternoon. Okay, let me just first, why is this not coming? Okay. Right. So sorry about last week, not last week, this Wednesday. So I know that, good afternoon, Tirina. I know that you completed up to, you talked about, you learned what identities are, and I'm glad that you met Kasana Madam, because she will be taking up your next two topics, the last two topics in Math 1 anyway, complex numbers. And yes, I am feeling better, not completely, but yeah, I'm okay. And since today it's just 1 hour, it should be okay. And this, and I know that you went through all the trigonometric identities. These are identities, okay? You know, like identity card. These are equations, but they are given the special name identity because for whatever value you put for the variable theta, or whatever, it's theta here, whatever value you put for theta, it's always equal. It's not like an equation. An equation, you have an unknown, and the equation is true only for one value that the one, or you know, when you have to solve the equation and find for what value it is correct. But for this, you put any value for theta on both sides, it's always, this side is always equal to the other side. Okay, so they're called identities. They're identical. That's a meaning, like, you know, identical twins. Twins line identical, they're exactly the same. So for example, this tan theta is identical to sine theta over cos theta. So they are replaceable. They are replaceable. You can, if you see a tan theta somewhere, you can replace it with sine theta over cos theta because they are the same. Okay, so identity means that you saw the Pythagorean identity and how it comes. You saw all the, so it's from sine squared theta plus cos squared theta is identical to 1. From that identity, it's actually the other two are two different versions of that same identity. I'm not sure whether you saw that. Now, if you take this, now this comes from the Pythagoras theorem, right? When you apply Pythagoras theorem to the right angle triangle in the unit circle, you see that this height is sine theta, this is cos theta. So you square these two sides and add them. It's equal to the square of the hypotenuse. So that's 1. So that's how that comes. And then if this equation, if you, this identity, if you divide the whole identity, every term in the identity by cos squared theta, you get this. If you divide the whole thing by sine squared theta, you get that. I hope you saw that. They are not 3 separate identities. It's 3 versions. Okay. You saw the compound angle formulas. Now here they are called formulas, but they are 2 identities. They are also identities. Okay. So they are called compound angles because you are given here how to write sine, cos, and tan of a sum of angles, a plus b, or a difference between 2 angles, a minus b. Because it's not, you might think, is sine a plus b just sine a minus, sorry, is sine a plus b just sine a plus sine b? Can I write like that? You might think whether you can just expand it like that. But that you can't do that. This is the correct expansion or the identity for sine a plus b and sine a minus b, and same for cos and tan. So you saw that too. And then double angle formulas for both of these. Famously, they are called formulas, but they are actually identities. Okay, if you are wondering, then identity ke liye par formula kiyana kiyala, if it's just how it is, it has been in the how it has come. So we are just using it, but they're all identities. These are double angle identities. Double angle means here you have sine, cos, tan of 2 times an angle, 2x, 2 times an angle, and I'm giving you an identity for that. And the other expression on the right hand side have half of the angle on this side. So for example, For example, say if you have sine 60, okay, I can write sine 60 as 2 sine what? Apply this. Sine 67. You can use a calculator and check this. Sine 2 sine 30 times cos 30. You can compute and see. Put any angle here. Sine of any angle is equal to 2 times sine half the angle times cos half the angle. Okay, so that's a cool identity. And you have similar ones for cos 2x and tan 2x. Now you have to know these identities, okay? And what's the usage of these identities? Why okay, it's fine, there are identities, there are expressions, they are identical, fine. What's the use of them? They can be used to prove further identities. Using these basic identities, you can prove or derive further identities. Tava identities derive කරගන්න පුළුවන් මේ basic identities පාවිච්චි කරලා. And also, when you have to solve trigonometric equations, to simplify certain things, you would have to use these identities. You might want to replace a tan x by sin x over cos x, like that. Okay, you can use the identities to replace one expression with another expression. For example, for example, you can prove this. This is another identity. I mean, there are millions of identities, okay? They all can be proved by the set of identities I have given in the previous 3 slides. So you don't have to remember these ones, okay? Basic sticker, you have to know, and using those, you can prove any of these identities. For example, if you want to prove this identity, did you do this slide 59? Did you discuss this slide? Yes or no?
No, ma'am.
No, okay. Okay, let's try to prove this identity. How do you prove an identity? You have to prove that the expression on the left hand side is identical to the expression on the right hand side. That's how you prove it. Make arakata equivalent bava tulya bava pennanna one. So what you can do is you take one side. You start with either the left hand side or the right hand side. They can etak gannawa, and then you simplify it until you get the expression on the other side. Dharmir, you can start with this and you have to simplify it until you get 1. Or you can start with this. That would be difficult. It's easier to start with this and maybe simplify to get the other one. So I will quickly show you that. So if you have to prove an identity like this, you choose the side that you can simplify. You can start from any side that you like, but you choose the side that you think you can simplify. So in this case, it's the left hand side. So you can say left hand side. In short, we say LHS, and you write what you have on the LHS: 1 over sine squared x minus cos squared x over sine squared x. And you have to keep simplifying this until with the aim of getting 1. Make a ekka dakwa sulu karana aramunin sulu karanna. So any suggestions? What can I do first? Because now these are 2 fractions and both fractions have the same denominator. Sine squared x, sine squared x. I can very easily combine these 2 into 1 fraction. Did you notice that I can write it as one fraction with 1 denominator because they both have the same denominator. And then I have here 1 minus cos squared x. Now you think, now in your mind, always, right? You have to keep thinking, I have to get one, I have to get one. Replace one by first Pythagorean. Very nice, Vishwa. Let's, I mean, here's another thing. There is no one way of doing it. I'm going to implement Vishwa's suggestion. Vishwa if somebody else is thinking to do so, yes, Nipun, do you have a different suggestion? Right? So you have that freedom. You will eventually get one. That's the nice thing. It's not like you all 500 of you have to somehow come up with the one way of doing it. You 500 of you might do, there might not be 500 ways, but there are so many ways. So Vishwa says to replace the one, this one, okay, I will highlight it, this one, with what the Pythagorean identity says, sine squared x plus cos squared x is equal to 1. So I will replace the 1 with, okay, Hasita says, do you see, you're looking at it in different ways. See what Hasita has written? Hasita says to replace the whole 1 minus cos squared x with sine squared x. It comes from the Pythagorean identity. But I will stick with, because Vishnu gave it first. So if I write, I'm replacing 1 with sine squared x plus sine squared x plus cos squared x. Okay. Instead of 1, make them, right? Because they are the same. Minus cos squared x over sine squared x. And now you have, right? And sine squared x over sine squared x is 1. You have proven that this is equal to the right hand side. Nipun says sine squared. Yes. Hasita and Nipun are saying the same thing. So that would also be the same. Yeah, okay. Right. So I hope that is clear. So that's one usage of identities. They are used to prove other identities, right? Okay. And what else? They are also used. So I showed you an example for how they can be used to prove identities. They can also be used to solve trigonometric equations. Now, so far, the trig equations you solved were very simple ones. You only had one trig term equals to a number. They are the most simplest trig equations you can ever find. But if you have a bit more complex trig equations, you might first have to simplify a bit. And for those simplifications, you would need identities. Okay. So if a trigonometric equation has more than one type of trig ratio, for example, has more than one type of trig ratio, the key to solving it is to first turn them into one type using trig identities. For example, look at this equation you will have to solve. Okay. You have to solve this. It's not a simple type of now I can mute you from my end, but I will not do that. Bashita, are you here? That means you are not even, you don't hear what I say. Me, Bashita. Phone ringing on. I can even remove. What I will do is I'm going to remove him. The reason why I do this is then Ogul Pasayata Kiana that I removed him. is because if you are logged in to the lecture, you can't be logged into the lecture and do other things. The monkey so if I feel that is happening, I really don't like that, so I removed him. So you can tell him later that I removed him. I could have just muted him from my end, but what's the point, isn't it? He was not anywhere in the lecture. Right. So look at this equation. Now you can see that it's not like the type of equations you had previously, where you only had one trig term equals to a number. So that was very easy to solve. Now this one has sec squared theta equals 4 plus 2 tan theta. Let me write that down here. Now there is a sec term, there is a tan term. Two types of trig terms are there. In that case, the first thing before you solve, the first thing to do is you have to try and turn them into the same type. Either you have to bring them both to sec or both to tan. Okay, so you have to think what you can do. Can I bring the sec squared theta to into tan terms or tan theta into sec terms? So this is where identities are useful. Does any identity come to your mind? Yes, Harsha, thank you. So what you can do is, this we have an identity where it says sec squared theta is 1 plus tan tan squared x. Right? It's an identity. So I will show, I will highlight and show. Oops, I don't want that color. Sorry, let me have a nice, like a color for that. This I'm replacing with that, right? That's an identity. Is equal to 4 plus 2 tan theta. Oh, it's theta, sorry, theta. Right? And now, shall I do it on the board? Wait, I'm copying the tan theta. Okay, let me take you to the right. What you had was, this is an equation. This is not an identity, okay? This is an equation. Make a samikaranaya. And we are solving it. This equation will be true for only certain values of theta. And we are going to find what those values are. We are solving this. So first step, I replace this with 1 plus tan squared theta. Now I have, it still looks complicated, lot of terms, but it's better than what I had before. Why? Because now I only have tan theta terms. Does anyone see a special thing about this equation? I have a tan squared theta and a tan theta. That means I have a square term. So I have tan theta. This is an equation of tan theta, and in that I have square of the tan theta and I have just tan theta. What type of an equation is it? It's trigonometric, but do you see another type in this because of the square?
Quadratic?
Yes, very good. Who said that? Was that, say hello?
Hello, madam.
Hansi, right, Hansi. Yes, it's a quadratic type equation, not a quadratic of x. Now, all the quadratic equations you have seen are of just a variable x squared. How do you recognize a quadratic equation? You have to have the power 2 of the unknown. Here, this is a trig equation. This is a quadratic equation of tan theta. Tan theta ge vargija samikarana. Okay, let me write that. This is important. This is a quadratic equation of x of tan theta. Of tan theta. Now, if you are finding it hard to see that it's a quadratic, let me do a small substitution. Let me relabel. Better labelating I will write this with a different label. Then you will see that it is a quadratic equation. Shall I? This is optional. I'm just doing this for you to be able to clearly see that it is a quadratic. If I make a little substitution, I am going to relabel. I think I would like to use the word relabel. I'm going to relabel. I'm going to relabeling. I'm going to relabel tan theta as x tan theta. Just to relabel. Harita me Harshata mang Sadeep kiyan patan ganna. Relabel. Okay, Harshava Sadeep karna. Harshava dana label venas karna. Just like that. Okay. So then what would my equation now look like? 1 plus what now? I have tan squared theta. If tan theta is x, what is that then? After the relabeling.
X squared.
X squared. 1 plus x squared equals 4 plus 2x. Then it's a quadratic. So I can, if I bring all the terms to one side, x squared minus 2x minus 3. Minus 3 equals 0. See, if I didn't do the relabeling, without doing the relabeling, if I just worked with tan theta, it would look like this is actually what it is. Tan squared theta minus 2 tan theta minus 3 equals 0. Okay, so it is it's a quadratic equation of tan theta. Now, because when I look at it, I feel better because it doesn't distract me with the tan theta. And so I will work with this because it looks familiar to all of us, isn't it? Can we factorize this? And I will show you side by side. I will side by side show you how it would look like if you don't do the relabeling and when you do the relabeling. Okay, so relabeling is not a must. I just did it to show you, I mean, how it could be done that way too. So minus 3 plus 1, correct? So here it would be tan theta minus 3 times tan theta plus 1 equals 0. And then you would say, so it's a quadratic now. So product of two factors equal to 0. That means x minus 3 equal to 0 or x plus 1 is equal to 0. That means x is equal to 3 or x is equal to minus 1. If you work with this, that is tan theta minus 3 equals to 0 or tan theta plus 1 is equal to 0. That means tan theta is equal to 3 or tan theta is equal to minus 1. So if you did the relabeling, you have to now bring back the tan theta. Then relabel you have to say, what is my x? X cube tan theta. So tan theta equals 3 or tan theta is. So you are coming to the same step. Right? The only reason you did this part, this is optional. Okay, for I mean, up to you. Okay, if you want to do like that, you can do that. It is optional. Optional. You could have just you could have done like this, right? Now, have we done solving? No, not yet. But do you see now we have come to two separate simple type two trig equations. We have two trig equations and they are both simple type, the type that we learned how to solve. We can solve. We can solve these two separately. How do we do that? So I will go to a new page. I have tan theta equals 3 and tan theta equals -1. I have tan theta equals 3 and tan theta equals -1. -1. So how do we do this? Did we have a range? Range එකක් දීලා තිබ්බද? මතක නැහැ. Yes, 0 to 2 pi. 0 to 2 pi. So if I do, I will draw my stations to Colombo, and I'm going to think, okay, my tan is positive. Tan is positive here, so I will get an angle in the first quadrant. And then tan is positive again in the third quadrant. I will get another answer here. So my two answers will come. I will get two angles, one an acute angle in the first quadrant and the other one a reflex angle in the third quadrant. Right? Here also, if I do this, I have here tan theta is negative. Where is tan theta negative? Here, that means I'll get an obtuse angle, and then here, that's again a reflex angle. So in the second quadrant and in the fourth quadrant. Now, how do we find it? You take the calculator, put theta equals tan inverse of 3. Tan inverse of 3. I'm in the degrees mode. Now, do you all understand how to use the degrees mode or the radian mode in the calculator? Do you all know how to change from one to the other? Do you all know that? Let me know. Okay, so I am going to do it in degrees mode for now, and later I will change it. So I get 71.56. This is my degrees answer, 71.56. So did I get as I expected? Have I gotten an angle in the first quadrant or the third quadrant? The calculator has given me the angle in the first quadrant. How do I find the other angle? That I can do. No, I can just answer. So you use a symmetry. So this, or what's my other angle? 180 plus. It's again 71.56. So, or I can, if I want to show you the working, 180 plus 71.56. Theta is 71.56 degrees, or plus 180. 250. How to memorize ASTC? So there are, I mean, you can make up your own thing for that. Okay, there are so many ways. People say different things. Samaharu kiyanawa all St. Thomas's College kiyanawa. Okay, yeah. Mama kiyana all stations to Colombo. You can make one. It's not a big deal. It's just 4 letters to remember. Anyway, okay, so 251.56. 5. The actual one is all stations to Central. It's like it's a UK thing, but we can adapt it to Sri Lanka, saying all stations to Colombo. Or Chilau, all stations to Chilau. Okay, so is that clear? I got the 2 answers in degrees. I think I need them in radians. If I were to do it in radians, I will use a different color and write in radians. I will first have to change the mode of the calculator to, right? I press 2, I go to radian then. Okay, now I have changed to radian. Now when I do tan inverse 3, when I press equals, now this is giving me the answer in radians, 1.2. Make a 1.2. That is radians. Or then how do I do this? What is 180 in radians? 2 pi plus 1.2. But it's not an exact answer. I think even in degrees, it's not exact. I think but that's what it is. Okay, so you can keep like that. So what is 2 pi plus? Because I mean, it's better to keep the answer in terms of pi, because pi is irrational, and if you try to find it as one answer, it will be again irrational. Okay, right? Is that clear? So this is in radians. This is in radians, 1.2 radians, or 2 pi plus 1.2 radians, or this is in degrees. Okay, the 2 answers. We are not done. We have another branch to do. So in this branch, if we do this branch, what's happening here? Theta equals tan inverse of -1. Tan. Oops. Ooh. Sorry. Tan inverse of -1. Tan inverse of -1. If I do it directly in radians now, I'm in radian mode. Tan inverse of -1. I press tan inverse of -1, and when I do equals, this is equals negative 0.78. This is radians. Okay. Which angle has the calculator given me? Now I knew I had decided, I had determined that my answers will come in the second quadrant and the fourth quadrant. That my 2 angles are going to be one in the second quadrant and the other one in the fourth quadrant. And the calculator has given me one of those 2. First quadrant or the fourth quadrant, negative 0.78. Fourth quadrant, it has very good. Yes, right? This is 0.78. So, but it's not in my range. I can't give my answer as that, because I need answers in the range 0 to 2 pi. Negative and the bear. So I have to figure it out as a positive.
Excuse me, ma'am.
Yes.
Excuse me.
Yes, Shainab.
180 degrees pi.
Yes, it is pi. Thank you. point Thank you, Shainab. Hassan, yes. Sorry, I'm just seeing that. Did you already? Yeah, it's pi. Yeah. Hemeva wenda puluwan mage atin. Mishaps eva ogolo ehinda you have to be hondata balan innawa monawa liyanawad danne naha. Be alert. 2 pi to pi ලියනවත් දන්නේ නැහැ. pi to 2 pi ලියනවත් දන්නේ නැහැ. x to y ලියනවා, y to x ලියනවා, theta ලියනවා, a to b ලියනවා, b to o ලියනවා. ඔය මේවා වෙනවා මට. Right. Okay. So minus 0.78. That angle as a positive angle, how much? So I have to work it out. It's shall we do it in radians now without going into degrees? So the equivalent angle for this is then 2 pi 2 pi minus 0.78, isn't it? Okay, let me actually work that out. 2 pi minus 0.78 is, okay, 5.50. 5.503 radians. That's one angle, so that's correct. Okay, that's the one in the fourth quadrant, and the one in the second quadrant. Make a kiyada. Do you see that? If this is 0.78, make a 0.78 neither. Vertically opposite pratimukha something. Thank you, Sadeep. Darshana, right? Vertically opposite angles are equal. So then my pink angle in the second quadrant is pi minus 0.78. Okay, so that is pi minus 0.78. I get 2.361 radians. Is that clear? I have 4 answers. This equation has 4 solutions. It was a quadratic equation of tan theta, and it has 4 solutions. Okay. And so the main takeaway here is, why did I solve this equation? To show you why we need identities, where we need identities in solving equations. We couldn't have solved this if we didn't have identities. Identities not because without this step, right? So these are the usages of identities. Let me clear this first. Okay, and there's another one. Would you like to try this? I have plenty of examples after this. Let me just check the next slide. Yeah, okay, so here I have some identities to prove and a bunch of equations to solve, and some more exercises, more, and then last topic is trig functions, trigonometric functions and their graphs. So this we will leave for Wednesday. We might need about 1 hour from Wednesday to do this. So I might ask Kasani madam to be there 1 hour after the lecture so that she can continue with the next topic. Okay, so my plan is that I hope I can finish this by on Wednesday, Kasani madam. Keep the answers in form of oh, okay. Right. Okay. So I think what you're saying is this. Now, if I go back to, oops, for example, all right, let's take the same example. Okay. Let's take this. Okay, tan theta equals 3. Say tan theta equals 3. Now theta is tan inverse of 3. Like that. The thing is, I mean, that is just very general, isn't it? You haven't computed the answer. It's like saying, yeah, there is a reason why she may have done it, because the answers we have written are not exact. Especially when we have to give it in terms of radians, if we are not using pi, if our angle doesn't come as a multiple of pi, pi ge ගුණාකාරයක් විදිහට අපේ උත්තරේ හරියටම ගානටම ආවේ නැත්නම්, we would be writing it as an approximate value. දශම ස්ථාන කීපයකට තියන්නේ, we would be keeping our answer to a couple of decimal places. Even in degrees, we have to do that. අපිට ගානට round ලස්සන උත්තරේ නැහැනේ. 24.394560 ඔහොම එනකොට අපි ඉතින් කපලා we will keep it to a certain number of decimal places. But මෙහෙම තියන්න කිව්වම ඉතින් හරි ලේසියි. ඔක ඉතින් මුකුත් කරන්න දෙයක් නැහැ. And you are not showing both answers. Yeah. I would say, so yeah, okay. So you know that your two answers come in this case, your two answers come in this answer here and here. So you can take this to be the angle. You can take this to be the answer here. So you can say theta 1. Okay, you can suppose that this is theta 1. So theta 1 is the solution in the first quadrant, the acute angle solution. You can assume that if it is tan inverse 3, then the other solution in the third quadrant is, say, if I call it theta 2, my other answer is tan inverse 3 plus pi. But the thing is this is fine. I think mathematically there's nothing wrong. But I want you to learn how to get it out, especially because you are technology students. When you are given an equation to solve, you have to know the value. You want to get a value for it. Tan inverse 3, I think, no, you have no clue. Using that's why we have the calculator. You find it and then actually find both. Okay, and in the exam you will be told to how many significant figures or to how many decimal places you need to keep your answer. So you should get the answer, isn't it? Yeah, so that's the clarification. Thank you for asking that, Vinura. Okay, so we have 15 more minutes. What we will do now is I will show you a couple of so I didn't do this one. I left this. Okay? I left this one. That is there. And we have all these. We'll do a few. We'll choose a few. Keep your thoragen api karamu. And these are there. What do you want to do? What do you want to do? I'll go back again. And the rest you can I can get Miss Kalpana to discuss, or if you want, yeah, Miss Kalpana tamai kiyane. Or if you want me to discuss, we can do that too. Would you like to pick a few? Shall we prove shall we prove a few? Okay, pick something from here. So these are identities to prove. Pick one.
D.
D. Okay. Let's do D. D it is. Let me copy it. You start. Yeah, that looks very difficult. Cos 2x here and then tan squared here with x. 2x with an x. One side 2x, other side just x. So if I take you to the board, what we had was 1 minus cos 2x over 1 plus cos 2x is identical to tan squared x. This is what we have to prove. Which side would you want to start off with? If you were to do this, මොන පැත්තෙන්ද ඔයගොල්ලෝ පටන් ගන්නෙ? Which side would you choose? Left or right? Huh?
LHS. Left.
LHS. Did you say LHS? Did you say LHS? Left hand
Yes,
side.
ma'am.
Huh? Right. Yes. Yes. I think so too. This is a good expression to start because you can do stuff to that. ඒකත් එක්ක මොනවා හරි කරන්න පුළුවන් දේවල් තියෙනවා. Tan squared x is just it's too small. Right. So let's start with okay. So we have cos 2x here. So double angle formulas have to come to your mind. We have for cos 2x, we have 3 formulas. Which one would you think of doing? So if I write them here, one is Martin. What's the first one? Who can remember? Shall I quickly take you there? Yeah. Okay. Cos squared x minus sin squared x. Also, you have 2 cos squared x minus 1. And the third one is 1 minus 2 sin squared x. Which one shall we use? How do we know which one? Is it random? Do we randomly choose one? Because now, what is in our head? Where are we aiming to go? We are aiming to go to tan squared x. None of these has tan in it. Make a got tan, sine and cos and sine. So then how do we decide which one to use? Anyone would work out of these 3. But for sure, there might be easier ones. Okay, so Shamila says that we have to remove the 1. I think that's a very nice way of thinking, because if you remove the 1, here both the numerator and the denominator have 1 minus 1 plus. If you can remove it and just get some cos or sine or some one thing, that's an improvement, because we only have to get tan squared x. So then, so are you suggesting to use, then okay, in that case, if you think like that, very good, Shamila. I actually like how, what Shamila thought. For this, do you think we should use 1 here and a different one here? What should we put for this? And what should we put for that? Okay, for the top cos 2x, what's the best one to put? If you want to remove that 1, if you want to get rid of that 1 in front, yes. See? That's how you think. I'm trying to, your chat box is too. Okay, so 1 minus, what did you suggest? Third one, 1 minus 2 sine squared x, okay? And for the bottom one, very good, cousin. And for the bottom one, if we are to cancel off the one in the denominator, you have to put this one, 2 cos squared x minus 1. Okay. What do you get then? 1 minus 1. This is going to be 2 minus into minus is plus. 2 sine squared x over minus minus cancel. 2 cos squared x. 2 cancels. This is 1. No, not 1. That's tan squared x. Tan squared x. Okay. Now, if you are thinking, if anyone here, if you are thinking that, if you are thinking like that, do we have to like think like that and choose? If you are thinking like that, this is actually the best way. If you think properly, you have to logically think. But if you try to do something else, you can try this. I will not do it. You try substituting a different identity and see what will happen. The thing is this, you will go in a very sidetrack. Finally you will come. So this is, if you like properly think, properly plan, I want to get rid of the one, then what should I put? If you think and do it, this is the shortest way of doing it. This might be the shortest way. I don't know. You might come up with a shorter way. Okay? That's the nice thing about proving identities. I think, like if you might do in a different way. Okay, let me go back to this again. Let's pick one equation from here to solve. Pick one. D. Asanga, D එක අපි කලින් solve කරපු එක වගේ නෙමෙයිද? Sec squared and tan x. It's similar. Make replace කරපු ගමන් it's going to be a I feel like, isn't it? We will do it if you want, but I think it's very similar to what we did earlier because it has the same two types, sec squared and tan. Okay, but it's okay. We'll do it. Okay, so everyone, you copy it and start doing. Shall I let you do it? Tani? Three sec squared x minus 10 tan x equals 0. And if one of you can send your solution as a picture, we can all look at it together. I can share it and we can look at it together. Not done yet? Okay, Sarah has the answers as, okay, I mean, that's not the end. So you have gotten to the step where you get the two simple equations. You have tan x, it's very similar, no? What we did earlier. Tan x equals 3. There, did we get the same thing? And tan x equals 1 over 3. So you need to solve now. Solve get x. What is x? But is that correct up to there? Now solving a trick. Okay, Lasantha, I think there has to be 4 solutions. Because this is a quadratic equation of tan. So for each of the equations that Sahara has written here, you will get 2. So altogether 4. But so I will write Lasantha's solutions here. You tell me whether they are correct. So this is for okay. Anushka has all. Okay, Anushka is written all. So this is for this. X is equal to 71.56, or these are in degrees. Yes, it's clear they are in degrees. 200 and yes, I have given you the range in degrees, so you can keep your answers in degrees. Okay, Nimasha has the same answers. Very good. That means they are correct. 250. 251.5 or 18.4 or 198.4. These are all degrees. 4 answers. And these come from the 2 equations. This or these solutions come from these 2 equations. Okay. Others, are you okay with that? Is everyone okay with this? So is it okay if I leave you all these to practice? I mean, the ones that come after this. Now, these are nice questions. I want you to try these out. And I'll tell you, on Wednesday, we will work out these. This exercise 8, these questions are nicely designed. So I actually want to do at least one question from this in class. Okay. So before starting trig graphs, we will do one in exercise 8. The rest you can try. Okay, Asira. Then can we wind up for today? Can we wind up for today? And just for your information, your assignment 2 due date is, I forgot, is when? I think it's over. Is assignment 2? Assignment 3, there might be an assignment 3. I will tell you about that on Wednesday. Okay. Yeah, that's all. Okay, so I'll see you on Wednesday, and Wednesday might be our last day with me, and hopefully we can start with Madam Kasuni. You can start the next topic as well. Okay, then shall we wind this up? Any questions? Or can we wind up? Okay, okay. Okay, then you all have a great week. I will see you on Wednesday. You're welcome, Vishwa and Nimasha and everyone. You all are very welcome. I will see you on Wednesday. Okay. Welcome. Bye.